For more videos like this for Discrete 1, you can take a look at Sarai's studies. Link is in the description box below. Is 2 an element of set A? Well, set A is here. Its elements are 1 and 2. Because I see 2 in the set, therefore it is true that 2 is an element of set A. Is 4 an element of set A? Well, set A is here. Its elements are 1 and 2. I don't see 4 in the set, so therefore it is not true that 4 is an element of set A. Is 3 an element of set C? Well, set C is here. Its elements are 1, 2, 3, and 4. So because I see 3 in the set, it is an element of set C. Is 10 not an element of set D? Well, set D is here. Its elements are 10. So already you know that 10 is an element of set D. So this is false. What's true is that 10 is an element of set D. Is the set containing 1 and 2 an element of set D? Well, set D is here. Its elements are 10, 20, and the set containing 1 and 2. So because I see this directly inside set D, then it is true that this is an element of set D. Is the set containing 2 and 1 an element of set D? Well, you go to set D, you don't see the set containing 2 and 1, but you have to remember that the order of sets doesn't matter. So this set right here can be rewritten as 2, 1. So because I see this set directly inside set D, therefore this set is an element of set D. Is 2 an element of set D? Well, set D is here. Its elements are 10, 20, the set containing 1 and 2, and the set containing the set that contains 6 and 4. Now, even though you see 2 somewhere in this set, it's not directly inside set D. It's actually inside this set. So we can't say that 2 is an element of set D, so this whole thing is false. Is 6 an element of set D? Well, in set D, I technically see a 6, but it's not inside set D, it's inside this set. So I can't say that 6 is an element of set D because it's not directly inside set D. So it is false that 6 is an element of set D. Is the set containing 6 and 4 an element of set D? Well, even though in set D I see the set containing 6 and 4, it's not directly an element of set D, it's actually an element of this set. This set here contains the set containing 6 and 4, not set D. So because of that, this is false. Is 1 an element of set A? Well, set A is here, its elements are 1 and 2, so because I see 1 directly in set A, 1 is an element of set A. So we're done using the symbols that we learned to describe sets. Now let's move on to using the symbols that we learned to describe relationships between two sets. So those symbols were subset, proper subset, and equal. So when you see these three symbols, the first thing you should check is if the two things of discussion are sets. So in this case, we have is 1 a subset of set A? Well, again, this symbol can only be used if these two things are sets. But this is an element, not a set, so this is false by default. And it's not false in the sense that, oh, we figured out that 1 is not a subset of set A. It's false in the sense that we can't even answer the question because the question doesn't even make sense. It's like comparing apples and oranges. They both need to be apples. They both need to be sets. Is 1 a subset of set A? Specifically, not just a subset, but a proper subset. That's what this symbol means. But we don't even have to think because the first thing you should do when using these symbols is check if both of these are sets. They're not. This is an element. This is a set. So it's false by default. Is set A a subset of set B? Well, again, you see this symbol. The first thing you should do is check if both of these are sets. They are. So now you can move on to finding out if this is actually true. So if it is true that A is a subset of set B, that means that all of the elements in set A should be in set B. So go to set A, its elements are 1 and 2, and check if those elements are also in set B. 1 is in set B, 2 is in set B. So it is true that all of the elements of A are in set B, so this whole thing is true. Is A a subset of set B? Not just a subset, but a proper subset. So from now on, I'm just going to say, is A a proper subset of set B? Again, you see the symbol. First thing you should do is check if both of these are sets. They are. A is a set, B is a set, so that's good. Now, unique to this symbol is that you have to check that these sets are not equal to each other, because if they are, it's false by default. So you go to set A, that's this. Set B is this. They're obviously not the same sets, so the only way that this is true after that is if it satisfies the condition of a subset. That means that all of the elements in set A are supposed to be in set B. And we already know that is true. If we go to set A, its elements are 1 and 2. 1 is in set B, 2 is in set B, so all of the elements of A are in set B. All of the elements of A are in set B, so this whole thing is true. So in other words, when you see this symbol, it's the exact same thing as this, except if they are equal to each other, then it's false. But because A and B are not equal to each other, then it's just going to be the same truth value as this. Is set B a subset of set C? Well, first thing, check, are both of these sets? Yes, B is a set, C is also a set, so that's good. And now you find out if it is true. If it's true that B is a subset of set C, that means that all of the elements in B are supposed to be in C. Is that true? Well, set B has elements 1, 2, 3, and 4. So are 1, 2, 3, and 4 in set C? Let's check. 1 is in set C, 2 is in set C, 3 is in set C, 4 is in set C. So because all of the elements of set B are in set C, all of the elements of set that B are in set C, it is true that B is a subset of C. Is B a proper subset of C? Well, the truth value is going to be the exact same thing as this. It's going to be true unless B and C are equal to each other. So just check. B is here, C is here. Are these sets the same? Yeah, they both are literally 1, 2, 3, and 4. So they're equal to each other, so therefore it is false by default. If they weren't the same, then it would just be true, whatever this was. Is this set a subset of set D? Well, first, are both of these sets? Yes, this is a set and D is a set. So now check if it's true. If this is true, that means that all of the elements in this set are also in D, meaning that 1 and 2 should be elements of D. 10 is an element of D, 20 is an element of D, the set containing 1 and 2 is an element of D, and the set containing 6 and 4 is an element of D. But 1 and 2 are not actually elements of D. They're not directly inside set D. They're inside this set. They're elements of this set, but not set D. So this is false, because not all of the elements of this set are in set D. Is this set a subset of set D? Well, first, are both of these sets? Yes, this is a set D is a set. Moving on, if this is true, that means all of the elements in this set are supposed to be in set D. So is 10 in set D? Yes, it is an element of set D. Is 20 in set D? Yes, it is an element of set D. Both 10 and 20 are directly inside the set D. So it is true. Is this set a proper subset of set D? Well, from now on, I'm going to assume you're checking if these are sets, so I'm not going to do that. But unique to this symbol, you just have to check that both of these are not equal to each other. One way to remember it is these are really just the same symbols. The only difference is that this has an equal sign, this doesn't. So that should remind you, oh, if this doesn't have an equal sign, then these sets cannot be equal to each other. If it is, it's an automatic false. So this is this set D is this one. Both of these sets are not the same. They're not equal to each other, so you can move on. Now, the only way it's true after that is if all of the elements in this set are also in this set. The elements of this set are 1 and 2, so you're looking for, is 1 an element of set D? 1 is not an element of set D, even though technically 1 is somewhere inside set D. It's not directly inside set D. It's actually an element of this set. So already it's false. You don't have to check the other one because you already have one element that's in this set that's not here. Is this set a proper subset of set D? Well, again, first thing you should do is make sure that these sets are not the same. Set D is this one, this set, and this one are not the same, so you're good. The only way it could be true after that is if it satisfies the condition of subset, which is that all of the elements in this set should be in this set. The elements of this set are 10 and 20. So is 10 in set D? Yes, 10 is directly inside set D. Is 20 in set D? 20 is directly inside set D. So yes, all of these elements of this set are in this set, so therefore it is true that this set is a proper subset of this one. Is this set an element of set D? Well, set D is here. I don't see this set containing 6 and 3, so this is false. Is this set an element of set D? Well, set D is here. I do see this set directly inside set D, so it is true that this set is an element of set D. Is this set an element of set D? Well, set D is here. I don't see the set containing 4 and 6, but I do see the set containing 6 and 4. And remember, the order doesn't matter, so I can switch these. This could be 4 and 6, and so then yes, I do see this set in set D, so therefore it is true that this set is an element of set D, because again, this can be rewritten as 4, 6, which is what I see here. Is set A a subset of set A? In other words, is set A a subset of itself? Because they're the same sets. So here's a fact. Every set is a subset of itself. That is always true. Now, I did do a video on how to prove this, so this is the video. It's under Sarai Studies in the sets section. Now, we know intuitively that this is always true because the definition of a subset says, okay, all of the elements in this set will also be in this set. And if they're the same sets, then that's always going to be true. All of the elements here will be in here because they're the same, so it's always true. So is B a subset of itself? True. Is C a subset of itself? True. Is D a subset of itself? True. For that very same reason. Is set A a subset of set E? Well, if this is true, that means all of the elements in A are supposed to be in set E. Is that true? Well, let's look at set A. Its elements are 1 and 2. Are 1 and 2 in set E? Well, I see 1 in set E. I see 2 in set E. So therefore, it is true that all of the elements in set A are also in set E. Is set A a proper subset of set A? Well, don't get confused and think, oh, because a set is always a subset of itself, then a set will always be a proper subset of itself. That's not the case, because remember, I said anytime you see this symbol, the one without the equal sign, that should remind you, oh, that means that these cannot be equal. They cannot be the same sets, and if they are, it's an automatic false, which is why it will never be true that we can say that a set is a proper subset of itself. That's always just false. Is B a proper subset of B? Again, you see the symbol, there's no equal sign. That should remind you these sets cannot be equal. They are equal, they're the same, so it's a false by default. Same thing for this. They're the same sets, false by default. Is D a proper subset of C? Again, you see the symbol, first thing you should do is check that they're not the same. Set D is this one, set C is this one. These are not the same sets, so we're good. The only way it could be true after that is if it satisfies the condition of a subset, which is that all of the elements in this set should be in this set. Is that true? Well, let's start with the first element in set D? We have 10. Is 10 in set C? No, so automatically we know that this is false because we already found one element that is in set D but is not in set C. Is set A a proper subset of E? Well, again, you have the symbol. There's no equal sign that should remind you these sets should not be equal. So check. This is set A. This is set E. Remember that order of sets doesn't matter, so this can be rewritten as 1, 2. So yes, these here are the same sets. So by default, it is false because when you're dealing with a proper subset, they can never be equal to each other. And they are, so it's false. Now, is this set a proper subset of this one? Well, again, no equal sign that should remind you these sets cannot be equal to each other. They are equal to each other because they're the same set. So it's an automatic false. Is the empty set a subset of set B? Well, here's another fact. The empty set is a subset of every set, and I already have a video where I proved it 2 ways. So it's under Sarai Studies in the set section in the discrete class. So it is true that the empty set is a subset of every set. Is the empty set a subset of the empty set? Again, the empty set is a subset of any set, no matter what it is. So this is true. Is the empty set a proper subset of the empty set? Well, here's another fact. It's the same thing as this. The empty set is a subset of any set except itself, because the whole definition of a proper subset is that these two sets cannot be equal to each other. So remember, anytime you see this symbol, remind yourself, oh, there's no equal sign. That means that these two sets cannot be equal to each other. If they are, it's an automatic false. So this is false because they are the same sets. Now, is the empty set a subset of set A? Again, this is true because the empty set is a subset of every set. Is the empty set a proper subset of set C? We know this is true because the empty set is a proper subset of every set except itself. Is 0 an element of the empty set? Well, remember, the empty set is literally a set that's empty, that has no elements. So 0 cannot be an element of a set that should not have any elements. So this is false. Is the empty set an element of this set? Well, I don't see the empty set in here. If it was 0, comma, the empty set, or 0, comma, an empty set, because these are the same things, then yes, this would be true. But it's not, so it's false. Is this set a proper subset of the empty set? Again, you see the symbol, it doesn't have an equal sign. That should remind you, oh, the first thing I should do is check if these are equal to each other. Well, this set is literally the empty set. This and this are not the same, so you're good. The only way that it could be true after that is if it satisfies the condition of a subset, which is that all of the elements in this set should be in this one. So that means 0 should be in the empty set, but that doesn't make sense because the empty set has no elements. 0 will not be in here, so therefore that is false. Is the empty set a proper subset of this set? Well, that is true because of the fact that the empty set is a proper subset of every single set except itself. Is this set an element of this set? Well, I don't see this entire thing inside this set. If it was 0, comma, the set containing 0, then yes, it would be true. But because I don't see this whole thing inside this set, it is false. Is this set a proper subset of this one? Again, I see the symbol. There's no equal sign. That should remind me I should check if these are equal to each other. If they are, it's a false by default. Are they equal to each other? Yes, they're the same set, so it's false by default. Is this set a subset of this one? Well, if it's true, that means that all of the elements in this set should also be in this set. Well, the only element in this set is the empty set. Is the empty set inside this set? Yes, it is, so this is true. Is the empty set an element of this set? Well, do I see this? Is the empty set an element of this set? Well, yes, I do see the empty set inside the set, so it's an element of this set. So this is true. Is the empty set an element of this set? Well, yes, I see the empty set directly inside this set, so it is true. Is this set an element of this set? Well, yes, I see this directly inside this set, so it is true. Is this set a proper subset of this set? Well, again, you see the symbol, there's no equal sign. That should remind you the first thing you should do is check if these sets are equal to each other. Are they the same sets? No. So that's fine. The only way that this could give you true after that is if it satisfies a condition of a subset, which is that all of the elements in this set should be in this set. The only element in this set is the empty set. So you're asking yourself, is the empty set in this set? Yes, it is right here. It is directly inside the set. So therefore this is true. Is this set a proper subset of this set? Again, no equal sign. First thing you should do is check if these are equal to each other. If yes, it's a false by default. These are not equal to each other. They're not the same sets. So you're good. Moving on, the only way that this could give you true is if it satisfies the condition of a subset, which is that all of the elements in this set should also be in this set. The only elements in this set is a set containing the empty set. So do you see this in this set? Yes, I do. It's right here. It's directly inside this set. So therefore it is true that this whole thing is a proper subset of this. Is this set a proper subset of this one? Again, no equal sign. That should remind you to check if these are equal first. If they are, it's a also false by default. Are these the same sets? Yes, because remember the order of the elements in the sets do not matter. So this can be rewritten as the set containing 4 and 5, which is indeed this same set. So this is a false by default. Is this set a proper subset of this one? Again, no equal sign. First thing you should do is check if these are equal to each other. If yes, it's a false by default. Are these equal to each other? Are these the same sets? No, they're not the same set. So the only way it could be true after that is if it satisfies the condition of a subset, which is that all of the elements in this set should also be in this set. Is that true? Well, the elements of this set are 6 and 1. So 6 is here, 1 is here. Okay. So the elements of this set are 6 and 1. So are 6 and 1 in this set? Well, I see 6 in this set. I see 1 in this set. So yes, it is true that all of the elements in this set are in this one. And so therefore, because they're not the same sets, this set is a proper subset of this one. Is this a proper subset of this set? Well, first thing, no equal sign. That should remind you we don't want these sets to be equal to each other. So that's the first thing you should check. Are these sets equal to each other? Are they the same? Now, you may be quick to say, no, they're not the same and move on. But that's wrong. They are the same. You have to look closely. First thing you should remember is that the order of the elements in sets does not matter. So yes, here we see the set containing 2, 3, but these are also the same sets containing 2, 3 because this can be rewritten as 2, 3. This can be rewritten as 2, 3. You're just switching them. So all of these sets are the same. And the second thing you should know is that sets cannot contain duplicates. So when you have copies of the same element, you get rid of all of them except one. And so at the end of the day, this whole set is just the set containing the set that contains 2, 3, which is exactly what we have here. So because these are the same sets and we know that these cannot be the same sets, it is false by default. Is this set a proper subset of this one? Again, no equal sign. That means these shouldn't be equal to each other. If they are, it's a false by default. So are these the same sets? Well, remember that sets cannot have duplicates, and this set has the same element twice. So you get rid of all the duplicates except one. And so at the end of the day, this set is just going to end up being the set that contains a set that contains the empty set, which is exactly what we have here. So because these are the same sets, and we know that these sets cannot be the same, then it is a false by default. Now is set A equal to set B? If they ask you to formally prove this, you're going to have to use the definitions. So you'll have to prove that A is a subset of this one and B is a subset of this one, and then you can say that A is equal to B. But right now you can see that set A is 1, 2, set B is 1, 2, 3, 4, so you know that that is false. They are not equal. Is set A equal to set E? Well, set A is 1, 2, set E is 2, 1. You know that the order of elements in sets do not matter, so this can be rewritten as 1, 2, which is the same set as this one right here, so that is true. Is set B equal to set C? Well, set B is here, it's 1, 2, 3, 4. Set C is here, it's also 1, 2, 3, 4, so they are the same sets, so that is true. Now in the next video, we'll talk about operations of sets. See you in the next.